Hello explorers, welcome back to the channel. Ever pondered over how an LED bulb is created? In the grand scheme of things, it's a question that may not keep you up at night, but the answer is surprisingly engaging. The humble LED bulb, after all, has sparked a revolution in the lighting industry. With its energy efficiency and long lifespan, it's become a household name and a symbol of sustainable living. LED bulbs have transformed the world of illumination, challenging traditional lighting methods. They've introduced a simple yet elegant solution that saves energy and lasts longer than conventional bulbs. This isn't just a light bulb we're discussing here. It's a testament to human ingenuity and our endless pursuit of better, more sustainable solutions. So how does this small yet powerful piece of technology come life? How do we go from raw materials to a product that lights up our lives, literally and figuratively? Today we will dive into the fascinating process of how an LED bulb is made. Before we delve into the manufacturing process, it's important to understand what LED is. LED stands for light-emitting diode. It's a tiny piece of technology that emits light when an electrical current passes through it. But unlike an old-school incandescent bulb, it doesn't have a filament that will burn out. This means it uses energy far more efficiently and lasts a lot longer. So why are LEDs used in bulbs? Well, there are quite a few reasons. First, they're incredibly energy efficient. Compared to traditional incandescent bulbs, LEDs use approximately 85% less electricity. This not only cuts down on energy costs, but it also reduces carbon emissions, making LEDs a more environmentally friendly choice. Secondly, they're durable and long-lasting. The average LED bulb can last up to 25 times longer than an incandescent bulb. That's right, you heard it, 25 times. That's a lot less time spent changing bulbs and a lot more time enjoying the light they provide. Thirdly, they're versatile. LED bulbs can be made in a huge range of shapes, sizes, and colors, and they can be dimmed to provide just the right amount of light. Whether you need a small, bright light for a reading lamp or a large, soft glow for a living room, there's an LED bulb that can do the job. Finally, they're safe. Unlike incandescent bulbs, which can get incredibly hot and pose a fire risk, LEDs stay cool to the touch. This makes them a safer choice for homes, especially those with small children or pets. Now, it's worth mentioning that while LEDs are more expensive upfront than traditional bulbs, their long lifespan and energy efficiency mean they end up saving you money in the long run. Now that we have a basic understanding of LEDs, let's move on to the actual process of making a LED bulb. The heart of any LED bulb is the LED chip. This tiny piece, often no bigger than a fleck of pepper, is the beating heart of our LED bulb. But how exactly does it come to life? Well, it all begins with semiconductors. Semiconductors are materials that are not quite conductors of electricity, but not exactly insulators either. They sit right in the sweet spot in between. Silicon is a popular choice for semiconductors, but compounds like gallium arsenide are also used in the making of LED chips. Next up is the doping process. This is where we introduce impurities into our semiconductor to change its properties. Don't worry, this isn't as bad as it sounds. These impurities are actually very important. They're what allow us to control the electrical characteristics of our LED chip. During the doping process, we create two layers of semiconductor material. One is doped to have an excess of positive charge, called the p-type layer, and the other is doped to have an excess of negative charge, known as the n-type layer. When these two layers are brought together, they form what's known as a p-n junction. This p-n junction is crucial. It's where the magic of light emission happens. When a voltage is applied across this junction, electrons from the n-type layer recombine with holes from the p-type layer. As they recombine, they release energy in the form of photons or light particles. This is the basic principle of how an LED chip emits light. Finally, to create the diode, we attach tiny wires to the P and N layers of the semiconductor. This allows us to connect our LED chip to a power source and control the flow of electricity through it. So, there you have it. From semiconductor to shining LED chip, it's a process that combines physics, chemistry, and a bit of electrical engineering magic. With the LED chip ready, we now move to the next step of the process. Now comes the fun part, assembling the LED bulb. We've got our LED chip ready, and it's time to bring everything together. The first step in our assembly process is mounting the LED chip on a heatsink. Why a heatsink, you ask? Well, even though LEDs are much more efficient than traditional bulbs, they still produce some heat. The heatsink is like a cool friend for the LED chip. It helps to dissipate the heat and prevent the LED from overheating. Once the LED chip is comfortably seated on its heatsink, it's time to add the bulb's outer casing. This casing not only gives our bulb its recognizable shape, but also serves as a protective layer. It shields the delicate LED chip and the electronic components from dust, moisture, and accidental bumps. Now, you're probably guessing what's next. Yes, you're right. The next step is attaching the electrical contacts. These little guys are the bridge between the LED bulb and the power source. They ensure that electricity flows into the bulb, allowing the LED chip to produce light. When you screw the bulb into a socket, it's these electrical contacts that make the magic happen. But wait, we are not done yet. The bulb needs a driver, a crucial component that regulates the current flowing through the LED. Too much current and the LED could burn out. Too little and it won't light up properly. The driver ensures just the right amount of current flows through, allowing the LED bulb to shine bright and steady. Assembling an LED bulb is a bit like working on a jigsaw puzzle. Each piece has its place and role, and they all need to come together just right. From the LED chip to the heat sink, the outer casing to the electrical contacts and the driver. Each component is essential in transforming electrical energy into light. We're almost done. The final step is testing. And that, my friends, will be our focus in the next scene. So, stay tuned. Every LED bulb undergoes rigorous testing to ensure it meets the highest standards. This phase, known as the testing and quality assurance stage, plays a vital role in the LED bulb manufacturing process. The first test that an LED bulb goes through is the light output test. This is a simple but crucial test that measures the amount of light emitted by the bulb. The aim is to ensure that the LED bulb produces the right amount of brightness. A bulb that is too dim or too bright is not fit for purpose. Next, we have the color accuracy test. This test is all about making sure the LED bulb gives off the right color of light. After all, nobody wants to live under a light that makes everything look green, right? Color accuracy is measured using a scale known as the Color Rendering Index, or CRI for short. A high CRI score means that the bulb can accurately show the colors of objects just like natural light. The third test is the lifespan test. This test is a bit of a waiting game. LED bulbs are left on for thousands of hours to see how long they can last. This is a crucial test because one of the main selling points of LED bulbs is their long life. If an LED bulb doesn't pass the lifespan test, it's back to the drawing board. But it's not just about passing these tests. The bulb must also meet certain safety standards. It's checked for any potential electrical hazards and to ensure it's safe to use in homes and businesses. Through these rigorous testing procedures, we can be sure that the LED bulb is not just bright and efficient, but also safe and reliable. Quality assurance is all about making sure that when you switch on an LED bulb, you can trust it to do its job and do it well. And there you have it, a fully functional, energy-efficient LED bulb ready to light up our lives. So, that's how a LED bulb is made. It's a fascinating journey, isn't it? From understanding the basics of LED, where we delved into the science behind these small yet powerful sources of light, to the actual manufacturing of the LED chip, the heart of the bulb. We saw how the LED bulb is assembled, a meticulous process that requires precision and care, and of course, the rigorous testing and quality assurance that ensures every bulb is up to par, providing us with reliable and energy-efficient light. LED bulbs have a significant role to play in energy conservation. They consume less power, last longer, and are a greener option compared to traditional, incandescent bulbs. They are a testament to how science and technology can contribute to a more sustainable future. Next time you switch on a LED bulb, remember the intricate process that went into creating it.